everybody, my goal today is to go through a couple of experimental design questions for you. Now this is for AP Physics 1, and these type of experimental design questions it's one of the 4 types that shows up on your AP exam. Now these experimental design questions can cover any of the topics from AP Physics, but they often ask similar style questions. And so in this video today, my hope is to go through some of the important things that you need to know, some of the ways that AP asks questions, help you understand exactly what are they looking for, what do they require, kind of what are the things that are going to be in that mark scheme that are going to help give you points, all right? Now, at the same time, I'm not going to work through every single question. I don't think that that's what I want to accomplish in this video. Really, I'm going to go through 2 or 3 different questions and just hit little bits and pieces so that you can see some of those commonalities, some of those things that happen in every single experimental design question so that you can get a little bit more comfortable with what exactly are they looking for. All right, so that's what we're going to do. In the first question, and I mentioned this can be any type of physics. This can be any type of physics from the whole year. In this one specifically, we're looking at an object with a parachute. Right? Now, a lot of times in AP Physics 1, we ignore air resistance. With the parachute is one of the few times where we should not ignore air resistance. Now, I'm going to go ahead and just step to the side. You can pause the video if you need to and read the problem statement. I'm just going to jump right into it because I don't want to take the time to do that. All right? But essentially, we have a mass, a block that has a known mass. We're going to connect it to a parachute, and we're going to drop it. Now, obviously, when we drop it initially, it's going to fall pretty quickly. But as it goes faster and faster, we start to get more and more air resistance, right? And at some point, it says that eventually it will reach a constant speed called terminal speed. Now, hopefully you learned about that in class. If not, recognize that terminal speed is what happens when you finally get to the point where the object is not accelerating anymore. It's falling at a constant speed, and it does say that, reaches a constant speed. All right? Now, if we look at the first part of this question, very often they will include things like free body diagrams and other types of things that will help you later on in the question. So this one specifically says that we have a dot below that represents the block parachute system when it has reached its terminal speed. Now, remember, the terminal speed means it's at a constant speed. Right there. On the dot, draw and label the forces acting on the system. Represent each force with a distinct arrow starting on and pointing away from the dot. Now, they won't always say this, draw relative lengths of all vectors, but if they give you a grid so that it's easy to kind of figure out lengths and things like that, you should definitely pay attention to the lengths of your vectors. Remember, the lengths represent the magnitude of those things. So in this case, we have the force of gravity, which would be down. And then we also have the air resistance, right? As the parachute is falling, air is going to push up on the parachute, which is going to cause the parachute to have an upward force. And so we're going to have this second force, which is the force of the air or the air resistance or something along those lines. Any of those is fine, all right? Now, what you'll notice as you look at mine is that because it's on the grid, I was really careful to show that this one was 2 boxes and that one is also 2 boxes. Those two have to be equal. If they're not equal, then it can't be a constant speed, right? Newton's first law says that an object with no unbalanced force or an object with no net force will maintain its state of motion. Right? That means it keeps the same velocity. So if it has this constant velocity, the forces must be balanced. So that's what they're looking for here. And very often, make sure if you have the grid, pay really, really close attention to the lengths, even if it doesn't talk about this, even if it doesn't say draw the relative lengths to match the relative magnitudes, because that should be a habit anyway. All right? Now, when we move on to the next part of the question here, this is also very common in AP questions. Sometimes they ask you to come up with an equation. We may do that later, but in this one they actually give you an equation. They say, hey, look, a group of students came up with this equation for dropping a variety of different objects. They say a collection of parachutes of different radii. So the same as before, these circular parachutes with a constant radius, but each parachute is going to be a slightly different size. And they found this equation on the internet that says the force of the air is going to be equal to some constant times the radius times the velocity squared. All right? F is the force by the air, R is the radius, V is the speed, and C is a constant. So the first thing they asked us to do is find the units for C. And again, this is a very AP-like question. They say, well, we're going to throw in a new constant that you've never heard of, you've never seen it before, but we want you to tell us what the units are. All right? Now, in order to do that, you're going to use the equation. Okay? We're going to use that idea of F. Oh, that's not a good mark. Let's try again. We're going to use the idea of F equals CRV squared. And I need to know the units of C. But in order to know the units of C, I'm going to look at the units of everything else. So force is newtons. But I want to break it down to its fundamental units. So the fundamental units, well, I know that force is mass times acceleration. And mass is kilograms. And acceleration is meters per second squared. So kilogram meters per second squared, that's the same thing as newtons. That's what is on the left side. That has to be equal to the units of C times the radius, which would be in meters, times the velocity squared. And velocity is meters per second, so I need velocity squared, which will be another meters squared per second squared. All right, now we just need to make sure that the units on both sides are equal. Right now, I see that there's a kilogram over here, but there's no kilograms over here. So therefore, the kilogram must be inside the C, must be part of the units for the C. So I'm going to put a kilogram there. All right, I see over here that there is 1 meters. Over here, there's 1 and then a meter squared, so there's 3 total meters over on the right side. That's too many. I can't have 3. There should only be 1 over here. And so in order to do that, I need to get rid of 2 of them. I need to get rid of that meter squared. So in order to do that, I'm going to go divided by meters squared. And so what you'll see is that the meters squared will cancel out, and I'll be left with kilogram meters per second squared, which now matches the other side. Now this is one way to do it, right? I just kind of put everything down and said what's missing. You can also put down all the units and then move everything over to the left, and whatever's left has to be the units for C. All right, but this shouldn't be an overly difficult question as long as you can break it down into the fundamental units. Always, if you get stuck with something like you don't know newtons or joules or watts or something like that, think about the equation for that and what units you would need to be able to work that out. Okay, so that's the units for C. Units of C would be kilograms over meters squared. All right, now the next part is really what I wanted to look at. The first two, yeah, those are common type questions. I wanted to look at those. But here's the piece that I think is probably this part C really here. This is probably the most important part of this. All right, so here they say again, based on the above equation for F air, derive an equation for the system's constant terminal speed in terms of R, C, physical constants, and other relative quantities that can be measured with equipment found in a high school physics lab. All right, so they want us to take that equation. Now remember the equation was F air equals CR squared V. Okay, so I'm going to write that down over here. F air equals CR V squared. All right, so that's what I start with. But the problem is I can measure radius and I can measure velocity, right? I can do those two. I can use a motion sensor to measure the velocity. I can use a ruler to measure the radius. I can't measure the force of the air. And so I need to then come up with something else. I need to come up with some other way to get that, all right? So the very first part of this question, they asked you to do a free body diagram. I will tell you this, on an AP exam, if they ask you to draw a free body diagram, I can guarantee you that within the next couple of steps, somewhere they're going to ask you to do something where you need to do Newton's second law. where you need to add up those forces or compare those forces or something, you're going to need to do something with Newton's second law that will allow you then to do something later on in the question. So you will remember that in my free body diagram, I had the force air going up and the force of gravity going down. What that meant is that the sum of the forces equals ma. So I had the air going up, so F air, and then I had gravity going down, so that would be minus Fg, and that would be equal to ma. But remember, it had constant speed, so it didn't have any acceleration, so this is 0. What I get from that is that the force of the air must be equal to the force of gravity. I know. You're saying, but Mr. Bauer, I knew that already because the free body diagram, the top was equal to the bottom. Yeah, okay. But what I'm trying to point out is that you may have a different question that has a free body diagram with 2 or 3 or 4 forces, that it will be helpful to remember that that's something where you're probably going to use Newton's second law. All right, so yes, I get it. On this specific question, you probably knew it without doing this work. However, my goal, remember, of this video is to teach you some of the things that will be helpful to you later in other questions. So, therefore, I can say the force of air is equal to the force of gravity, and we know that the force of gravity is equal to mg. And that m is the mass of the block, which was given as mb at the very beginning of the question. You can rewind it if you need to double check that. So I'm going to take this, and I'm going to substitute it for F air. So what I end up now is mbg is equal to CRV squared. Just like that. Now those are all things that can be measured in the high school lab, right? I can measure the mass of the block. I already know what G is. That's one of those physical constants that it mentioned, right? It said, right here, indicate, physical constants, right there. It's there. See, physical constants. And then I've got the C, I've got the R, I've got the V, the terminal velocity. Terminal velocity is important because that's when these two things are equal. That's when this is true, right? And so therefore, we now have all things that we can measure. Now, obviously, the point of this is we're trying to figure out what C is. And that's what the next piece is here. It says, indicate below what quantities could be measured and then graphed to determine whether the equation derived in part CI correctly relates the parachute's radius and the terminal speed of the block parachute system. All right, so what we want to do is we want to be able to create a graph. Most of the time, we want a linear graph. And I know it doesn't say linear graph here, but I'm going to go ahead and do linear graph anyway, because that's what's going to help you in the future. I would say 4 out of 5, 9 out of 10 times, they ask you for a linear graph. Okay? In this question, sure, you could. So I guess here, if we wanted to do that, we're going to. What are our 2 variables here, right? What can we change? We can change the radius, and that should then affect the velocity here, right? The terminal velocity. So those are our dependent and independent variables. I can change the radius. That's my independent variable. The VT will change as a result. All right? So when you do this, you can put independent on one side and dependent all by itself, right? Usually it's y equals mx plus b. It really doesn't matter, right? When we do it here in physics, we really just want one variable on one side and one variable on the other side, all right? So I'm going to go ahead and I'll just go ahead and put v on on one side because that makes v the y, right? When I'm thinking about a linear graph, I need y equals mx plus b, and v is my dependent variable, so I'll make that b by itself. So I'm actually going to move the c over to the other side, and I'm going to move the r over to the other side, all right? So I'm going to divide by c first, so I'm going to have mbg over c, and then I'm going to divide by the r, but I'm going to write it this way, times 1 over r, because that's actually my variable, right? That's the one thing that I can actually change, and that will be equal to VT squared, just like that. All right, so when it's asking what should I put on the vertical axis and what should I put on the horizontal axis, if I want a straight line, which is generally the best way to do this, you want this to match y equals mx plus b. You want the equation to match up with your slope-intercept form. Now, if you do this, the x and y will be your variables. That's why I made such a big deal about those two things being my variables earlier. So y is going to be one variable, and you'll notice that that matches up with the v squared. So on my vertical axis, I'm going to put vt squared. All right, that's what I'm measuring using my motion sensor. We talked about that. And then on the x-axis, notice that I have a bunch of constants here. The mass of the block is constant, gravity is constant, and that c is constant. So that's a whole bunch of constants. That is going to be m, and then x is being multiplied by that. So x is 1 over r. And so I'm going to put, for the horizontal axis, 1 over r. And if I put 1 over r on the horizontal axis for x, and I put v squared on the vertical axis for y, I get y equals mx plus b. Now, there's no b in this one. That's pretty common. Again, 4 out of 5, 9 out of 10 times, you're probably not going to have a plus b there. A lot of things that we do in this class will end up being some type of direct relationship where 0, 0 is a common point. All right? But, so in this case, we're not going to worry about the b, but hopefully you can see the y and the x matched up. Everything else is part of m. All right? So on the axis below, sketch a graph showing the relationship between the two quantities indicated in part CII and based off the equation in part CI. So again, if I put 1 over r down here, and I put vt squared over here, the whole point of that was it gives me a linear graph, and so I can go, boop, done, right? That's it. That's my graph. Now, if you didn't do this, if you put some other form of v or r on there, you're going to have to figure out what the mathematical relationship is. So this is why I recommend, even if it doesn't say linear, if you will follow this procedure, you'll get a linear graph. Now, most of the time, they are going to ask for a linear graph, and so you're going to need to do it anyway. All right? But here we go. Let's see. Is there anything else here? The next step of this is design an experimental procedure. I'm not going to go into that right now. I may look at that in one of the future questions, but right now I'm going to skip that because that's not really what I want to focus on here. Okay? The only thing really to talk about is you do need to be very clear with this. You need to write down what is it that you're measuring. For me, I said I was going to measure the radius and I was going to measure the velocity, the terminal velocity using a motion sensor, and I said I was going to measure the mass of the block, right? So I would write down those are the three things. I'd put their symbols here. The symbols need to match anything that I've done prior, okay? Don't make new symbols if they have already defined some symbols for you. And then I'll write down the equipment that I use to measure it. Okay, try not to make up equipment. Use equipment that you've used before or that you know about because that means that it's definitely in a high school classroom. Okay? All right, we're going to skip the rest. We're not going to go through the setup or this piece because, like I said, the whole point of this today is I want to look at some patterns, some things that are common between these types of questions. All right? So let's move on to the next one. Again, if you want to read all the words on this question, you can. You can pause it. Let me scroll it up just a little bit. Okay, from there you should be able to read the introduction of the problem. But essentially, we've got a block. The block is hanging on a spring, right? It's hanging from a ring stand. The block is pulled down 0.5 meters, so 50 centimeters, and then they release it that allows it to oscillate. As it oscillates, we have a certain period, right? So what they're doing is they've changed the mass each time, and they're getting a period based off of that. Now, that should sound familiar, especially since my class did that in class, right? You actually tried out several things to see what would affect the period of an oscillating spring, and that was one of the things we tried different masses to see if it affected. And the answer was yes, it did, which we can also see here. Now, the first question here, if we scroll up just a little bit, we understand the problem now, is they want to determine the spring constant. And so therefore, again, you'll notice this is very similar to the question that they asked before. They want us to indicate which quantities could be graphed to determine the spring constant. Now this time they do say by using a best fit line. Best fit line, they're talking about a straight line, friends. Okay? They may not say straight or linear or proportional, but that's what they mean. Okay? So find a best fit line. So we already know we need to somehow get this connected to y equals mx plus b. And we already know our variables, right? We know our variables are mass and period. And so either y or x needs to connect to mass, and the other one needs to connect to period, right? So now we need to come up with the quantities. Now, anytime they ask this question, you need an equation. Now, in the first one we did, they gave us the equation, right? But this one, they didn't give us the equation. But, like I said, we already did this. We know this. And so we're actually going to get the equation. Now, if you don't know the equation, you should pull out your equation sheet, because you're going to have your equation sheet on your exam. And if they expect you to write an equation, the equation is either going to be on your equation sheet, or you'll be able to build it by substituting things that are on your equation sheet. All right? So, for example, on this one, if I pull out my lovely equation sheet, I can find right here the period of a spring is equal to, here it is, 2 pi square root of m over k. All right? So I'm actually going to write that down here. So period of a spring is equal to 2 pi square root of m over k. Oh, no plus. Sorry, I'm thinking about my y equals mx plus b already. Now, you may look at that and you may know what we need to do. I'm going to go ahead and do one more math step, because for some of you it may be helpful. All right? So you can actually probably already see, I'm going to use my other color here so that it's clear, that y is going to be the period, right? And that does happen to be the dependent variable. It doesn't have to be, but in this case it is. So I already know on my vertical axis, I'm going to put the period. Done. Okay? Now, what am I going to put on the x-axis? Well, remember in the other question, like I said, I'm looking at patterns here. In the other question, we put all the constants into the m, and the variable was part of the x. You don't have to do it that way, but I find if I do that every single time, then I have a pattern, I have a system, I have something that I'm working with. All right? So what I'm going to do is I'm going to take this square root of m over k, and I'm going to rewrite it, because the m is the variable there. So I want the m to be in the spot of the x, and I actually don't want the k to be there. So the way I'm going to rewrite this is I'm going to rewrite it as ts equals 2 pi. Now I'm going to rewrite the square root as square root of 1 over k times the square root of m. Right? And if you are somewhat confident with your mathematics, you should be okay with that, because you would know that this is just m over 1, and I could multiply those and it would take me back to the m over k. Now, if that's something that you're not comfortable with, you probably should review your mathematics with radicals, right? With the square roots or with exponents. You can always rewrite that as a m over k to the 1/2 power, right? If that's something that's not comfortable to you, then it's not the physics that's your problem, it's the math that you probably need to go and review. But what you'll notice now is that I still have that t, which is my y value, and now the x value is going to be the square root of m there. So that's what I'm going to put on my horizontal axis, is the square root of m. Now, if I do that, then I get a straight line. because I have y, I have x, and everything else must then be the slope. That's how it works every single time. The math is amazing, right? Math is a great tool that we can use in physics to help us do things, okay? Now, in the next part, it says plot appropriate quantities to determine the spring constant of the spring using a best fit line. I am sorry, I'm not going to take the time to graph it. You see the data points there. You can use the data points to graph it. What I am going to do is I'm going to skip up here, and I'm going to show you how we would use a best fit line to solve for, again, it's asking us to solve for the spring constant using the best fit line. Now, sometimes they don't say use the best fit line. Sometimes they say using the graph. If they say using the graph, they mean either use the slope or use the y-intercept. Okay, and that's something that you have to remember because that's what AP means when they say use the graph. If all you do is take a couple of points from the table and plug it in here, because that's the tendency of students to say, oh, well, the table gives me mass and it gives me t. I'll just plug those numbers in and solve for k. Guess what? You didn't use the graph. And in this one, you definitely didn't use the best fit line. So you can't just plug in points. You must use the graph. Now, if you have zero idea what to do, you should at least be able to plot this, right? You should be able to take that table and you should be able to put the points down. If you can't do that, then you're really in trouble. You better talk to your physics. Actually, you better talk to your Algebra 1 teacher, right? Because that's when, maybe even pre-algebra, when you learn how to graph points on a graph. So you have to be able to do that. If you are in doubt and don't know what else to do other than graph it, just calculate the slope. Calculate the slope. Get 2 points on the line, calculate the slope, because 9 times out of 10, that's the answer. You need the slope, all right? Maybe it's not the answer, but at least it's the right process to get there. Let me show you. So I'm not going to go through this because, again, I'm not going to go through all the details. But if I have some points on here, okay, and notice that my points aren't perfect. It's not a perfect straight line, but they are decent. What I'm going to do is I'm actually going to now grab a meter stick and I'm going to draw a straight line. Now, I do notice that in my equation, I don't have a plus b. So I am actually going to make this go through 0, 0 if I can. Oh, sorry, I've got some masses on there. I couldn't find a good meter stick. So more or less something like this. I feel pretty good about that. All right. Just do your best to fit the points. There should be a couple above, a couple below. If you draw the line and you're like, oh, those points aren't in a straight line, then you probably made a mistake and you need to go back and fix it. Don't just leave the straight line there, right? If your points look like this, then you probably need to go back and figure out why you're not getting a straight line. This should give me a straight line. If I put the square root of m down here, and I put t over here, it should give me a straight line. Now, you'll notice that my graph took up most of my paper. That's one of the things that they often look for. If you cram all your data into this small area, then you're probably going to have a larger amount of uncertainty and they'll probably take off a point or not give you a point. You need to make sure that your graph covers at least half of the area that's given. Okay, so stretch it out, use the axes creatively so that you can make sure to use the entire graph or most of the graph. All right, from there, I now have a line. Now that I have a line, then I'm going to use the line of best fit to solve for the spring constant. Okay? Now, to use the line of best fit, what you're going to do is you're going to either find the slope or the y-intercept. In this case, the y-intercept is 0, so I'm not going to use that. That's not helpful. I'm going to calculate the slope. Like I said, if in doubt, just find the slope. You probably need that anyway. So I'm going to go slope equals, and I would actually have to do y2 minus y1. Do not take 2 points from the table. That is not using your line. Take 2 points from your line. Now, if you want, you can use 0, 0. That's a really nice point. If it goes through 0, 0, you should use that point. and then choose another point that's way over here somewhere. Don't choose points close together, because sometimes they'll take a point off for that as well. Because the closer the points are, the more uncertainty there is in the possible line there. So choose points that are far apart so that the line has to go through those 2 points. Choose a point that's easy to estimate, okay? If the point is on the line, okay, then it's okay to use that point, but make it clear that you are using those 2 points, okay? When you do your math, do y2 minus y1 over x2 minus x1. Don't take a shortcut and say, oh, this is 0, 0, so it's just y over x. Don't do that. That's not making it clear that you use 2 points on your best fit line to get the slope. Okay? Make sure that you make it clear. Put the 0, 0 in. Subtract 0. The math isn't hard. I know. Just write it down. All right? Once we have that, then you should get a value for the slope. You get some number there. Once you have the number, we go back to the equation. Remember, in the equation, the square root of m was x. What that means is that the slope is everything else. So this stuff right here, that is the slope. And so once I have a value for the slope, then I'll say, well, that means slope, whatever that number is equal to 2 pi square root of 1 over k. And then you end solve it. Plug it into your calculator, get a number, right? That's it. Then you got k. Or if you really want to, you can divide by 2k, and then you can square it, and then you can flip the fraction, right? You just solve for k at that point. It's just algebra. Okay, but you don't even have to do the algebra. AP doesn't expect you to do that, right? You're going to get 1 point for showing that you calculated the slope using 2 points on your best fit line, and then you're going to get 1 point for getting K. That's it. All right? There's no extra points for all the lovely algebra in between. So if you like your in-solve, use it. Okay? No problem. So hopefully you can see how that question in many ways was similar to the previous question, how we're using that y equals mx plus b. In the first question, they gave us a random equation. They'll do that sometimes if it's physics that we don't know yet. Or we had to come up with our own equation based off of the variables that were being measured. And then I was able to do it that way as well. Okay? Just remember these things about using the graph. If it says use the graph, slope or y-intercept. Okay? Don't just pick points and use the points. That's not using your graph. That's using the data table. Okay? All right. I'm going to skip. Okay, we're not going to do the rest of this one because I think that, again, that's not the point of this video. I'm going to look at one more because I got a minute. So, in this question, I've got an eraser. I've got like 7 erasers. Okay. All right. So, group of students, this should be near and dear to your hearts. So we just wrapped up fluid mechanics. So we've got a fluids question here. Okay, a group of students is given a cylindrical container half filled with a liquid of unknown density, as shown unknown density. Huh? Guess what we're going to do in this question? Something's unknown. We're going to know it, right? All right, as shown in figure 1, the students have access to an additional container with more of the same liquid. That just means you can pour it out, you can add in, you can do whatever you need, change the amount of fluid in there, whatever. You have meter sticks and you have a pressure sensor. Lovely. I have no idea what a pressure sensor is, but I guess it measures pressure. All right. So my assumption is I can stick it in there, I can put it wherever I want, any height that I want, and it will measure the pressure for me. Okay. If you've used a pressure before, great. If you've never used a pressure sensor before, it is a sensor that measures pressure. Get over it. Just use it, right? And they may introduce something that you haven't used before. I've tried to introduce some things to you. I'll introduce some more things to you in class, but if they give you something else, say, oh, thanks, that's lovely, and just use it, okay? they don't have access to a scale, so you can't actually weigh it. So they're trying to get around saying, oh, let's use the meter stick to measure the volume, and then we're just going to put it on the scale, we're going to measure it, and do mass over volume and get density. Yeah, they don't want you to do that. That's cheating. So there's no scale, but you are allowed to measure pressure. All right? Okay, in part A, we're going to indicate quantities that could be measured by the students that would allow them to determine the density of the liquid using a linear graph. That sounds familiar, right? Just like every other experimental design question that we've done. They want us to give quantities, what goes on the x-axis, what goes on the y. It's asked a little bit differently, but it's the same question, right? Now, what can we measure that would allow us to determine the density? Okay, well, remember I have a meter stick and I have a pressure sensor. So I can definitely measure pressure. Okay, so I can definitely measure pressure. I can definitely, I'm trying to get density. So do I have an equation that connects pressure and density? They're not giving me an equation, so that means I got to come up with it. I have to use my physics knowledge, which is pretty darn good, to come up with an equation. And you'll remember down here in the fluid mechanics equations, you've got something that measures pressure at a given depth, right? Pressure equals rho g h. And so therefore, pressure, rho h. I can measure h with a meter stick. Yeah. So let's go. Pressure equals rho g h. Okay, now remember here that h is the depth of the fluid above the point that you're measuring, right? So the higher the fluid is, the deeper you are, the more pressure there is. All right? Now, they do want the quantities we can graph on horizontal and vertical axes. They're not asking us to explain how we're going to get that. They're just saying, what do we need to put on a linear graph? So, once again, we're going to use y equals mx plus b. Once again, you're going to notice there's nothing being plussed there, so we're not going to even have plus b. We just want y equals mx. Now, what can I measure? What are my variables? What's going to change? Well, I can use my meter stick to measure how deep I'm measuring, and I can use my pressure sensor to measure the pressure. And so therefore, pressure and height are the two things I can measure. Density is a constant, right? The density of the fluid is not changing. G is a constant. And remember, that's what we said, is that very often the constants will go in with the m, and the variables will be the y and the x. So let's go ahead and do that. So what goes on the y-axis? Pressure. What goes on the x-axis? Depth. Don't put height unless you clarify. But really you want to be clear and say, I'm going to put the depth in the fluid at which I measure this pressure. Okay? Be clear, especially with things like time and distance and length. Don't just say, I'm going to use length. Length of what? You measuring the length of your big toe? I mean, come on. You got to be clear what you're measuring. Don't just say time. I'm going to measure the amount of time from when I release it until it hits the ground. I'm going to use the amount of time from when it passes my nose at certain velocity until it passes my waist, right? That amount of time right there. Define the time. I'm going to do the amount of time that it takes something to sink from the top of the liquid till it hits the bottom, right? Be clear for anything like that that's quite general, like length and time and things like that. Okay? Mass. Mass of what? What are you measuring? Okay? All right, so we know that y is going to be the pressure that we're going to measure, and x is going to be the depth that we're going to measure. All right? And that's the quantities. Now here it says, briefly describe the relationship between the density of the liquid and a feature of the graph from part B. Your answer may include an equation that relates density to a feature of the graph. Okay, so essentially, remember they did say to create a linear graph. It does create a linear graph because it's y equals mx plus b. Okay, And now it wants us to explain essentially how are we going to use the graph, feature of the graph, to calculate density. This is the same thing that we've done, right? Are you seeing the patterns? This is almost every single experimental design question. This is like half of the question, okay? So hopefully what you're recognizing now is that the slope is going to be equal to the density times g. And so that's all you would write here. You would say the slope is equal to the density times g. And so all I need to do is take the slope and divide by 9.8, and the result is the density. All right? Cool, right? Now, one of the things that I do want to mention here, right? Because we've got the indicate the quantities it could measure, describe the, sorry, I skipped describe the method. I don't want to spend too much time on the method. I kind of just skipped straight from here to here. That's fine, because that was, I was looking forward, that's what I wanted to accomplish. The only thing really that I want to mention here in the method, other than being specific, which I kind of already talked about that, the other thing I want to mention in method, one of the things that they are going to look for is what did you do to decrease uncertainty? Okay? Taking one measurement is not enough. Okay? As a minimum, absolute minimum, you either need to take multiple measurements at a certain value. Like in this case, you could probably do that. You could say I'm going to take 5 measurements at a depth of 10 centimeters. And that would work. That wouldn't really give you a linear graph. So I think you'd have a difficult time. That would allow you to get the density, but it wouldn't allow you to get a linear graph. But as an absolute minimum, you got to do multiple trials. Secondly, what you need to do is you need to make sure to have multiple different values of each of those variables. So I'm going to test a depth of 10 centimeters. So I'm going to use my meter stick. I'm going to measure a depth of 10 centimeters. I'll put a mark on the side of the container, and then I'm going to put the probe at a depth of 10 centimeters and measure. I'm going to pull it out, and then I'm going to try it again. And I'm going to measure I'm going to do 3 different trials at 10 centimeters. Then I'm going to use my meter stick to measure a depth of 20 centimeters. I'll put a mark there, and I'll put the probe down to 20 centimeters, right? Maybe you talk about, I'm going to make sure that the probe goes in the water, but my liquid, but my hand is not, because the hand would cause the fluid to rise a lot more than just a probe. We have to assume that the probe won't make too much of a difference, or it's not a very good probe. But add in the 20 centimeters, and then I'm going to do the same thing for 30 centimeters, 40 centimeters, 50. You learned about this in grade 10, grade 9, grade 10 science, right? You should have at least 5 different values and have multiple trials of those values. Now in AP Physics, I usually recommend 7 to 10 different values and at least 3 trials. You're not doing the experiment, right? You're just explaining how to do it. It doesn't matter if it would take 3 days to gather all the data. You just need to make sure that there's enough data and that there's less uncertainty. So if you want to do 10 centimeters, 15, 20, 25, 30, 35, 40, 45, that's 9 different values, great. And then say I'm going to take 5 trials of each. It doesn't matter. You're not going to do it. You don't have to complete it in the next 15 minutes, right? You just explain it. So the big thing here is make sure that you have a method to reduce experimental uncertainty, right? And they'll usually say that as part of the describe. And they're not asking you for what can you do to reduce error in your measurement. But they want you to talk about the uncertainty in terms of like random error, which is something that you can solve by taking multiple trials, right? Multiple trials at each depth, multiple different depths, right? And that should be your common. That should be common in any experiment you create here. That's going to be a point, okay? I'm not going to go into the rest of the question. I think I've accomplished most of what I wanted to here. And you can go back. I would review everything, but really the big things are you need an equation to match to y equals mx plus b. The variables, the two things that you're measuring, that's x and y. Match that up. It may be linear x to h, but it may be, remember we had 1 over r in our first equation, right? So it doesn't have to just be that variable, but it has to be a mathematical kind of a change to that variable, okay? All the constants generally will then go into the slope, because then that will make everything constant. You'll be able to solve for whatever your unknown is when you solve for the slope, okay? When creating your experiment, multiple trials, multiple different data points. When you're creating your graph, make it cover the whole graph. Make sure that you choose 2 points that are far away from each other, and that you're super clear when you're writing out your slope that you're using 2 points that are physically on the line. Okay, not close to the line, they have to be on the line. It doesn't have to be one of the data points from the table. In fact, it's better to not use points from the data in the table, because you're being clear that you're using 2 points that are far apart, again, to decrease uncertainty. All right? So anyway, I hope that video has been helpful to you. I hope that helps as you start to see more types of questions like this on your exams and things like that. Okay? See you next time.